geometry students, we're still in section chapter 1, section 3. We're going to do example 3 right now. This one, the congruent angles, we do arc marks. You know, remember the tick marks to show congruent segments, to show congruent angles. We do arc marks to show that. And there's a couple different styles that I've seen in the past. Let me kind of get up here and show you. Let's say you wanted to show those two arcs, those two angles as being the same. You could show them as one arc. I've seen it this way as well, where you're trying to show angles are the same. You could say, okay, these are two different angles from the original two that are drawn up here. So to distinguish them, I can either do two arcs like this to show that these two are equal, and then the single arcs are equal. I've also seen it where they've done something like this, where they've, you know, shown a tick mark through the arcs. There's lots of different ways that you can show that angles are congruent. And, you know, we're back here. I'm going to circle this part of it. We're going to use that congruent sign, the squiggle over the equal sign, to show congruency. We're saying that these angles are the same, and we're going to name them in the appropriate way. So angle ABC is congruent to DEF, and you can definitely do that. This construction, there's no way I can do this construction. You and I need to do this together. If you would like to try and follow the directions on your own, you do need a compass. So you can emulate this angle A that's listed here. You can just wait for me. You can try it at home. Either way, we're going to go over it in class. So I'm going to leave that to your own devices. Let's go ahead and flip to the next page. And we have another postulate that we need to address, the angle addition postulate, which is very similar to the segment addition postulate. And you're going to find such similarities here. And I think you're going to connect to this pretty quick. All right, so we have S is our interior ray. It's in the center or in the middle of somewhere of angle RQP or PQR. And we can use segment addition or angle addition to show that if I add angle PQS, which is shown in the red, and I add that to angle SQR, which is in blue, although why they have these colors backwards, I don't know, then those angles together form the big angle PQR. So that's pretty cool, and we call that angle addition postulate, and that's how we shorthand it right here. So definitely learn that shorthand. We will create shorthand for some of these things as they pop up. All right, so example 3, we're using the angle addition postulate to help us solve for something that we don't know. They're going to give us some things we do know, and then help us, we're going to use this information, this equation, to help us find what we don't know. So we know that angle ABD is 37 degrees, okay? And we know that ABC, the whole thing, is 84. And so this is what we're trying to find as DBC. We don't know that. So what we do know is angle ABD plus the other little angle DBC is equal to the big angle ABC. We do know that much. Okay, that's true according to the angle addition postulate. So let's plug in what we know. We know 37 degrees plus x is equal to 84 degrees. And then we're going to do just basic math here, basic algebra, subtract, and we've got x is equal to, what we got, 47? So that missing angle is 47 degrees. Okay, and this is simple enough. I think just showing it to you one time is all you need. So I'm going to give this, check it out. I want you guys to try that. Do it on your own. You can write right there on the angles, create your equation, show me your work so I can see that you understand how to set this thing up, okay? One last thing is you're probably wondering why they have this little m in front of it. That technically means the measure of. The measure of. And so it's, whenever we're talking about the actual measure for an angle, we're going to put that little m out in front. So if you were wondering why that was there, that's why. Okay? All right. Thank you very much.